which is a good compound answer for an exam if you're right. So then, because this is removed from this equilibrium can shift towards the air, motor can be removed, so everything can be funneled through this, even though it's unfavored.
Okay.
So the last thing I'm going to talk about will be amine formation, but in this case we did amines with, we used a secondary amine. So what happens if instead of using a primary amine with one R group, what happens if we use a secondary amine? So if you do this mechanism again, I'll let you guys do it for practice. The amines, it's the protonation event, the addition, the elimination, everything's going to be identical to this, except you have a secondary amine instead of a primary amine. And so what that will give us at first is our amine. But when you use a secondary exam, there's one key difference. So in this case, with the primary amine, we have a hydrogen we can deprotonate by water to give us our neutral compound. In this case, there's nothing that can be removed from the nitrogen to give a neutral compound. So what happens? When we use a secondary amine, what do you think happens now? What happens is if we have a hydrogen adjacent to the carbonyl, this becomes really acidic. The same reason in the Swern oxidation, the carbon hydrogens adjacent to the sulfur plus were acidic. This is the same thing because there's a positive charge here. These hydrogens become really acidic, so much acidic now that water can deprotonate them, giving us our neutral product. Here. So with secondary amines, we don't get the aminium, we get the double bond migrating one bond because of the acidity of those protons. And the acidity of these protons is going to really come a lot into play in chapter 18. That's pretty much the core of chapter 18 and chapter 19. But just be aware, when we use secondary amines, we get the carbon-carbon double bond linked to a nitrogen from the carbon.